Hi, this is Dr. Emenacker. In this video, we're going to look at one thing only. Where did the product rule come from anyway? For each of the derivative rules that we're going to be studying in this course, you can come up with a proof or a derivation where each of them comes from. Okay, it's not just true for the product rule, but for the quotient rule, the chain rule, for the power rule. For each of the rules, there's a similar process that can be followed to actually demonstrate that, yep, this stuff is accurate. But what we're going to do is we're going to just focus on one of these instead of going through all of them. And the one we're going to focus on is the product rule. Okay, if you'll recall, there's a theorem that says if f of x and g of x are differentiable, when the function capital F is equal to the product of these two functions, the derivative is going to be f prime g plus fg prime. That's the rule. Okay, great. That's the rule. Where did it come from? Actually, this rule, as all the other rules, the quotient rule, the chain rule that we'll get to, power rule, they all come from using this limit as h goes to 0 applied to a difference quotient. If you take a look at the derivative, it's going to be equal to the limit as h goes to 0 of the function with h of x in it. Recall that the original difference quotient is f of x plus h minus f of x over h. This says we're going to take whatever our function is that we're working with. In this case, it's this product. And we're going to substitute in x plus h. Minus, then we're going to take the function and substitute in x, divide by h. So what we have at this first step is just the application of the difference quotient to the function we're going to work with. Okay, now the first step that we're going to take here is kind of an interesting one, and in math there are some intriguing ideas that come up. But before we take this step, let's look at something fairly simple, or consider something fairly simple in the upper right-hand corner. If you have something like 3 plus 7, is it true that that's equal to 3 plus 4 minus 4 plus 7? And you might think about that for a minute and say that's kind of an odd way to go about it, but yes, it is equal because when you add the 4 and subtract the 4, in essence, you've done nothing to the original function. You've added something in, but you've taken it out, so it really isn't there anyway. Well, what's going to happen in the product rule is we're going to do something like that. At the top of the screen, we have our original function with the difference quotient. Now, look what happens here at the second step. We still have this term, and we still have minus this term over here. But in the middle, in addition to those two terms we've just looked at, we have minus f of x, g of x plus h, plus f of x, g of x plus h. It may seem a peculiar thing to subtract from and add in, but you'll see in a minute that it sets things up very nicely. The point that I want to make here is we've taken and we've subtracted a term and we've added it. So in essence, we have not changed the numerator's numeric value. Okay, just like what we saw up earlier with the 3 plus 7 is equal to 3 plus 4 minus 4 plus 7. Okay, so it's kind of a tricky maneuver, probably a new one for you, but that's what mathematics is about, is some tricky maneuvers here and there along the way. Now, what we have at this point is f of x plus h, g of x plus h, minus f of x, g of x plus h. Then we also have plus, and we have a second set of terms in the numerator. I'm going to take this fraction and break it into two pieces. Well, is it okay to do that? Sure. Suppose you had 3 over 7 plus 2 over 7. That's equal to 3 plus 2 over 7. And we're used to working from left to right in this. However, it's equally true because of the equal sign that you can move from right to left. You can take a single fraction and break it up into two individual fractions. So what I'm going to wind up doing here at this next step is to take the first two terms in the numerator, put them there, the second two, put them there, and I've actually done two steps here. When you look at these first two terms, notice they both have a factor of g of x plus h. I factored that out, leaving me with the f of x plus h minus f of x over h. For the second term, I still have a limit as h goes to 0. If you look at the two terms in this second box, you'll notice they each have a factor of f of x. Okay, what I've done here is to factor out the f of x like that, leaving in the numerator g of x plus h minus g of x, and it's still all over the h. Okay, so there's the next step. Where we go from here is this next line right in the middle of the screen. Now, g of x plus h. We can substitute the 0 in for h here because we don't have an h in the denominator. We can't substitute it in here because it would be undefined, so that's not going to work. But in this first term, we can substitute in h goes to 0. After we've applied the limit, we can pull that function out front times the limit that remains, and we have g of x times this limit as h goes to 0, f of x plus h minus f of x over h. In our second term, we have an f of x. Notice this does not have a variable h in it anywhere. So the fact that the limit is sending h to 0 in no way impacts this particular function because it doesn't even have the variable h in it. So we can bring it out front like that. And what remains on this second portion is the limit as h goes to 0, g of x plus h minus g of x over h. Okay, so we've got that done. Now, if you take a look at this whole piece, this limit of this difference quotient, this whole thing by definition is f prime of x. Similarly, looking in the second term, this limit of this difference quotient is by definition g prime of x. So what I can do at the next step is I can continue bringing down my g of x. In place of this whole deal with the limit as h goes to 0, I can replace that with f prime of x. In the second term, I can continue to bring this f of x down, and this difference quotient with the limit as h goes to 0 can be rewritten as g prime of x. Okay, well that's got that squared away. And what we now have is a situation where we have g times f prime of x plus f times g prime of x. The only thing I'm going to do is I'm going to reverse the order of these two factors. You can do that. 3 times 2 is the same as 2 times 3. And that gives us then f prime times g plus f times g prime is the derivative of the product. That brings us to the product rule that we were presenting earlier, that we were practicing in an earlier video. And it allows you to see that this actually does come from a legitimate set of mathematical steps using techniques that you've already developed, your limits and a difference quotient.